All right, now let's talk about the speed of sound in air. We have a very handy dandy formula that the velocity of speed and sound in air is 331 plus 0.6 t. Now, we're not going to worry too terribly much about units. Just know that the speed is always in meters per second. And for these examples, the temperature has to be in Celsius. So if we were to graph, all right, I know y'all just love these. If we were to graph the speed of sound versus temperature, what would it look like? Well, it would have a y-intercept of 331. So we're going to pretend like this is 331 at 0t, and then it would go up, and the slope would be 0.6. So as it gets warmer, the speed of sound gets faster. Now, sound pulses emitted by a dolphin travel through 20 Celsius ocean water at 1,450 meters per second. So that's a speed, and this is a temperature. So in water, let's look at this. The temperature is 20 Celsius, and the speed is 1450 meters per second. In air, the pulses, same temperature, the speed is only 343. What's the difference? Well, in water, the molecules are very close to each other. They're not fixed like in solid, but they're pretty close together. While in air, the molecules are much further apart. So remember, sound waves are longitudinal waves, so when they vibrate, the speed of sound is much faster here because it's much closer to the next molecule. While here, the molecule has to travel quite a bit further to propagate the sound. So why? Because in water, the molecules are closer than in air. This exact same argument can be used to describe why sound travels faster through solids than through liquids. Now, give the speed of sound through air in each temperature. All right, so I know V is 331 plus 0.6 T. In this case, T is 14.6. I'm going to write this out. So this is 331 plus 0.6 times 14.6. Now, folks, you need to go on and multiply these two numbers together first. 0.6 times 14.6 is 8.76. Then add. So you want to multiply 0.6 times t, and then add to 331. Okay? So 331 plus 8.76 is 339.76 meters per second. All right, for this one, the temperature is 25.7 C. So the speed is 331 plus 0.6 T. That's your formula, so now you're going to plug in 331 plus 0.6 times 25.7. Remember what your first step? First step is do this multiplication. 0.6 times 25.7. So, let me go back. This is 331 plus, I'm going to put this in red so you can see it. This is 15.42. And after that, you add the two numbers together. All right, so 331 plus 15.42 is 346.42 meters per second. Now give the air temperature when the speed is. So in this case, I gave the speed is 356.8 meters per second, and I want the temperature. Okay, so we're going to need to do some solving. If V is 331 plus 0.6 T, we're looking for T. So let's do this solving. All right. First thing I'm going to need to do is subtract 331 from both sides. So this becomes V minus 331 is 0.6 T. Let me switch colors. Now I'm looking for T, so I'm going to divide both sides through by 0.6. So T is V minus 331 divided by 0.6. Now for both of these examples, I'm show you how to put this in your calculator, or how to do the solving. Here T is, let's see, V in this case is 356.8 minus 331 divided by 0.6. Okay, your first step is subtract your numerators. All right, subtract in your numerator. So 356.8 minus 331 is 25.8. So T is 25.8, and then carry your denominator, which is 0.6. Your next step is now divide. So 25.8 divided by 0.6 is 43. And don't forget your units. All right, let's try and do this one down here. Now I've already done the computation. My velocity is 326.4 meters per second. So I've already done all this. I'm not going to do it again. You don't have to do it for a part B. So I know the temperature is V minus 331 divided by 0.6. So now I'm going to plug in. I'm going to start doing it in different colors for you. So T is my velocity, which is 326.4 minus 331 divided by 0.6. All right, so the first thing I'm going to do is subtract. So 326.4 minus 331. Now I'm getting negative 4.6. That's okay. All right. This is negative 4.6 divided by 0.6. All I did was the subtraction first. Keep the negative sign. You're going to need it. All right. My next step is to now do my division. All right. Negative 4.6 divided by 0.6 is negative 7.67 Celsius. You can have negative Celsius. Just means it's below freezing. What is the frequency of sound in air at 25 Celsius? So I have my temperature. I'm going to call that a C. Let me start over here. C is 25 Celsius. It has a wavelength of 0.84 meters. Okay, now folks, this one you've got to combine a couple things. We're looking for frequency. We do not have the speed. So the first thing you need to do is find speed of sound in air. When you have a temperature and I need a speed, I know V is 331 plus 0.6 C or T. You can call it T or C. I've called it both in this one, haven't I? Let's go on and call this. I hate being confusing. All right. All right. So this is 331 plus 0.6. T is 25. All right. Remember your first step? You have to multiply 0.6 times 25 first. So this is plus 15, and you're going to have 331. And now you add 331 plus 15, and you get 346. So now I have V, and I want the frequency. V is F lambda, so the frequency is V divided by the wavelength. So it's 346 divided by 0.84. Let's see, 346 divided by 0.84 gives me 411.990 hertz.